Hi, this is Bono. Today I'll explain what current is and which way current flows. Up to last time, we talked about how current flows once a circuit is connected all the way around. But that current, what is it that's actually flowing? And which way does it go? Today we step into that. Actually, this episode has a slightly curious point that makes you go, huh? The first time you hear it. But once you understand the reason, it's nothing to worry about. Watch with an easy mind. In this video, we'll start from what current is, then the particle carrying electricity, the electron, and finally the convention by which the electron and current directions end up opposite, in order. If you'd like to get current clearly straight, please watch to the end. First though, let's look at what current is. Current is the amount of how much electricity passes through a cross-section of a wire or part per second. Put another way, it's a number representing how much electricity is flowing. The thing carrying the electricity is the particle called the electron, which we'll talk about next. Think of current as expressing how many of those electrons pass through per second. A good picture is flow in a water pipe. Turn the faucet and the amount of water passing per second goes up, right? It's the same. Current expresses how much electricity passes through per second. The important thing here is that current is not the speed the water flows at, it's the amount that passes through. And for the size of this current, we use a unit called the ampere. Here it's enough to just remember the name ampere. So the point of this chapter is that current is the amount of electricity that passes through per second. Next is the story of what exactly carries that electricity. Inside a metal, say a wire made of copper, there are many tiny particles called electrons. These electrons are the very thing that actually moves inside the metal and carries electricity. Remember the electron as a particle with negative electricity. Inside a metal, electricity is carried by these electrons moving. And how many of those electrons pass by per second? That's what we express with the quantity called current. To put it as an analogy, it's like same-sized boxes riding along a conveyor belt. Each box is an electron, and the more boxes that pass by per second, the bigger the amount of electricity passing through, that is, the current becomes. One distinction to make here is that the electron and current are different things. The electron is the particle itself that carries electricity. Current is the amount of how many of those particles pass per second. Keeping in mind that their roles differ makes what follows much clearer. Next up, the biggest point of today, the electron and current directions. This is the spot I mentioned earlier. First, let's look at the direction the electron moves. In the wire connecting the batteries, two terminals on the outside, the external circuit. That is, the electron comes out of the minus terminal and moves toward the plus terminal, from minus to plus. However, the current direction used in circuit calculations is the opposite. Current is defined as coming out of the plus terminal and heading to the minus terminal. The electron that's actually moving goes from minus to plus. Yet the current direction is from plus to minus. They face exactly opposite ways. Why has it come to this? It's because the current direction was decided based on which way it would go if positive electricity moved. A convention, in other words. To put it as an analogy, it's close to a bookkeeping rule. It's like deciding to write the event a minus thing moved left as a plus thing moved right. What actually moves is the electron going left, but the direction reference, the current, is the opposite, going right. Still, as long as the rule is unified across the board, the answer to the calculation comes out right. So even if you hear the directions are opposite, don't worry. For basic circuit work, thinking with the convention that current goes from plus to minus is fine. Here's a field note. Why is it that the electron and the current directions are still opposite? Actually, this is a trick of historical timing. Back when the study of electricity began, the particle called the electron hadn't been found yet. Around that time, the names plus and minus for electricity were born, and based on the idea that the electricity flows from plus to minus, various calculations and laws were built. But later the electron was discovered, and it turned out that what actually moves inside a metal is the negative electron, going the opposite way. So you'd think, why not just correct the direction? But the direction convention is a solid usable rule that gives the right answers as long as you use it consistently. Switching the direction now would gain almost nothing and only add the trouble and confusion of realigning textbooks and figures all over the world. So we may as well keep using the original convention. Because of that history, in the field we still deliberately use current direction and electron direction separately. Knowing there is this kind of history behind why it's opposite is kind of fun, isn't it? Now a quick check to test how well it landed. This time too, 3 questions you'll trip on, unless you really get it. Take a moment to think. Question 1. Current means the speed of how fast the electrons race. Is that true or false? Question 2. Look at the figure. On 2 wires, A and B, the electrons that passed in the same 1 second are shown as dots. A has 6, B has 3. Which has the bigger current, A or B? Question 3. Electrons move from the minus terminal to the plus terminal. So is the current direction used in circuits, from plus to minus, correct? True or false? Have you settled on your answers? Let's check them on the next page. Alright, let's check the answers. Question 1's answer is false. Current isn't speed, it's the amount of electricity that passes through per second. It's different from the speed of the electrons. Question 2's answer is A. Current is decided by how many electrons pass per second. In the same 1 second, A has 6, B has 3. The one with more passing through A has the bigger current. Question 3's answer is correct. The current direction is a convention based on positive electricity going from plus to minus. It's the opposite of the electrons that actually move, but calculate with this direction and the answer comes out right. How many did you get? Go back over any you missed. So today we've talked about what current is and the current direction. First, current was the amount of electricity that passes through per second. And the main carrier of that electricity is the particle with negative electricity, the electron. That's exactly why in the wire outside the source, that electron moves from the minus terminal to the plus terminal. However, the current direction used in circuits is the opposite, from the plus terminal to the minus terminal. This was an old convention of deciding the direction based on positive electricity. Even though the direction is opposite, if you use it consistently across the board, the calculation comes out right, so it's enough to just remember that current goes from plus to minus. Looking at it this way, the amount called current, the particle called the electron, and the convention about direction all connect into one thread. These are all foundational for thinking about circuits. Please keep them in a corner of your mind. That's all for today. Thanks for watching.